So let's dive into the geological history and formation processes of the Eye of the Sahara, which is also known as the Richat structure. This fascinating and unique circular formation has captured the imagination of scientists, researchers, and enthusiasts alike for decades. Located in the Sahara Desert of Mauritania, the Eye of the Sahara is a prominent circular feature spanning approximately 50 kilometers in diameter. It's composed of concentric rings of various types of rocks, such as sedimentary, metamorphic, and volcanic, which have been exposed over time. The striking appearance of the Richat structure has led to numerous theories and investigations into its origin. To understand its unique circular appearance, we need to look back in time to its geological history. The Eye of the Sahara was formed during the early stages of the Earth's crustal development around 100 million years ago. At that time, the region was covered by a shallow sea, and over millions of years, layers of sedimentary rocks formed as the sea retreated. As the African continent shifted and moved due to tectonic forces, the weight of these sedimentary layers caused the underlying mantle to rise, creating a dome-like structure. Over time, erosion by wind and water wore away the outer layers of sediment, exposing the underlying rings of diverse rock types. The Richat structure's unique appearance is a result of the various geological processes that have occurred in the region, such as erosion, tectonic uplift, and volcanic activity. The combination of these processes has created a captivating and mysterious geological marvel, which continues to intrigue scientists and researchers today. All right, let's now explore the various scientific theories that attempt to explain the formation of the Eye of the Sahara. There are several competing ideas, including those related to erosion, volcanic activity, and even extraterrestrial impact. First, let's discuss the erosion theory. Over millions of years, the forces of wind and water have shaped the Earth's surface, and the Eye of the Sahara is no exception. As I mentioned earlier, the Richat structure was formed from a dome-like uplift of the Earth's crust, which was then subjected to erosion. The concentric rings we see today are a result of the varying resistance of the different rock layers to erosion. This theory is widely accepted by the scientific community, as it provides a plausible explanation for the formation's unique appearance. Another theory suggests that volcanic activity played a role in the eye's formation. While there is evidence of volcanic rocks within the Richat structure, it's important to note that there is no central volcanic vent or eruption site. Instead, the volcanic activity may have contributed to the overall geology and uplift of the region, rather than being the primary cause of the eye's formation. Finally, there is the intriguing extraterrestrial impact theory. Some researchers have proposed that the Eye of the Sahara could be the result of a massive meteorite impact. The circular shape and the presence of shocked quartz, a mineral found at impact sites, lend some support to this hypothesis. However, there is a lack of other evidence, such as a prominent impact crater or an abundance of other impact-related minerals, making this theory less likely than the others. In conclusion, while erosion and volcanic activity seem to be the most plausible explanations for the Eye of the Sahara's formation, the extraterrestrial impact theory adds an element of mystery and fascination to this already captivating geological wonder. Now, let's examine the role of satellite imagery and remote sensing in discovering and studying the Eye of the Sahara and how this technology has been crucial for geological research. Although the Eye of the Sahara was first discovered in the 1930s by a French pilot, it wasn't until the advent of satellite imagery that its true scale and beauty were fully revealed. From high above, the Richat structure is even more striking, with its concentric rings appearing like a bullseye in the vast expanse of the desert. Satellite imagery and remote sensing have been instrumental in studying the Eye of the Sahara for several reasons. First, they provide a valuable means of mapping and analyzing the region's geology without the need for extensive ground-based expeditions. This is especially important in remote and inhospitable locations like the Sahara Desert, where field research can be challenging and costly. Second, these technologies allow researchers to monitor changes in the landscape over time, helping them to better understand the processes that have shaped the eye and the surrounding region. For example, by comparing satellite images taken at different times, scientists can observe how erosion and other geological processes continue to impact the Richat structure. Lastly, satellite imagery has opened up new avenues for interdisciplinary research, as the Eye of the Sahara can be studied in the context of broader geological, ecological, and anthropological questions. For instance, scientists can investigate how the formation has influenced local climate patterns or affected the distribution of plant and animal species in the region. In summary, satellite imagery and remote sensing have revolutionized the way we study the Eye of the Sahara and other geological wonders around the world. These technologies have not only unveiled the beauty of the Richat structure, but have also provided valuable insights into the Earth's geological history and the processes that continue to shape our planet. Now, let's delve into the intriguing connection between the Richat structure and the myth of the lost city of Atlantis, as well as the archaeological evidence that either supports or refutes this hypothesis. The legend of Atlantis, a highly advanced civilization that supposedly sank into the sea, has captivated the imagination of many for centuries. The ancient Greek philosopher Plato first mentioned Atlantis in his dialogues Timaeus and Critias. According to his account, the city was located beyond the Pillars of Hercules, which are believed to be the modern-day Strait of Gibraltar. This has led some researchers to speculate that the Eye of the Sahara could be the remains of this lost city. So why do some people believe that the Richat structure could be Atlantis? Well, there are a few intriguing similarities. First, the concentric rings of the Eye of the Sahara are reminiscent of Plato's description of Atlantis, with its series of circular canals and city walls. Second, the geographical location of the Richat structure is not too far from the Pillars of Hercules, making it a plausible candidate, at least in terms of proximity. However, there are several significant counter-arguments that challenge this theory. For one, the timeline doesn't match up. The Richat structure was formed around 100 million years ago, while the story of Atlantis was said to have taken place around 9,000 years before Plato's time, which would be roughly 11,000 years ago. This discrepancy alone casts doubt on the idea that the Eye of the Sahara is the remains of the fabled city. Additionally, archaeological excavations in the area have not uncovered any evidence of a highly advanced civilization or any human artifacts that could be linked to Atlantis. Instead, the findings point to a more modest human presence in the region, with no indication of the grandeur and sophistication described in the myth. In conclusion, while the connection between the Richat structure and the lost city of Atlantis is a fascinating hypothesis, the available geological and archaeological evidence does not support this theory. The Eye of the Sahara remains a captivating and mysterious geological wonder, but its association with Atlantis is likely just another captivating tale in the ever-evolving story of this enigmatic place. Finally, let's analyze the ecological and anthropological aspects of the Eye of the Sahara, focusing on its impact on local communities, regional climate, and the broader Sahara Desert ecosystem. The Richat structure, with its unique geology and striking appearance, has undoubtedly influenced the surrounding environment. The presence of various rock types and the uplifted nature of the formation create microhabitats for different plant and animal species. For example, the Eye of the Sahara is home to several endemic species, such as the Barbary macaque, which can be found in the nearby mountainous areas. From an anthropological perspective, the Eye of the Sahara has also played a role in the lives of local communities. For centuries, the area has served as a landmark and navigational aid for nomadic groups, such as the Tuareg people, who traversed the vast desert landscape. Moreover, the presence of water sources within the Richat structure, such as springs and wells, have provided vital resources for these communities in an otherwise arid environment. The Eye of the Sahara may also have implications for the regional climate. Its unique topography and geology could potentially influence local weather patterns, such as rainfall, by interacting with prevailing winds and atmospheric conditions. While more research is needed to fully understand the specifics, it is clear that the Richat structure plays a role in the broader Sahara Desert ecosystem. In conclusion, the Eye of the Sahara is not only a geological marvel, but also an important ecological and anthropological feature. Its unique characteristics impact local communities, regional climate, and the broader Sahara Desert ecosystem, adding yet another layer of intrigue to this captivating natural wonder.